Okay, so this is the college's oil tank. This is a Bunded oil tank. I'll just come back over here. So you can see on the front here, we have the control panel. Here we have the data badge. Tells you all the appropriate details that required, capacity, etc, etc. These here are the lifting eyes for manoeuvring it into place. We have a cover that covers, in this case, it covers the 2-inch fill connection. These are the sensors for the bundle arm, low level and high level. This is the inspection cover. This here actually comes from here, which this is the return line. If this was a 2-pipe system, it would turn inside, up and over and back into the tank. This here is the vent pipe. It vents from the tank inside out through the outer bunding skin and vents back into the bunded area in the front. I'll show you that from the front of the tank in a wee second. And this is our outlet connection with an isolation valve. There's a separate isolation valve again inside. So that's the front cover open. You can now see all the material, the components inside. Starting with the very first component, off the bottom of the tank, we have a valve. The valve is connected via a long rod here to give us an extension that allows us to remotely operate that valve without actually having to go into the depths of the tank. This area here you see here, this is the bund. This is the actual oil tank that holds oil. So this holds 50 litres of oil. You can see there's a gap all the way around it. And this tank has been designed with a capacity of 110% the volume of that. So from the outlet there, you can see it comes along. Comes along up here and through the first component on the pipeline. This is a strainer. So this strainer filters us down to roughly 1 to 2 millimeter particle size and basically protects all the pipeline components from this point onwards. We'd isolate the valve, remove that, and we can take out the strainer basket and clean the strainer basket and put it back in again and tighten that back down again. Next device we've got on it here is a solenoid valve. Solenoid valve will be connected into a couple of different components. One of them will be the overfill alarm, another one would be the control panel inside the premises, and also it could be connected to a fire alarm as well. Moving along, see if we can get the camera. Moving along, next component we've got pipe work going along, it branches off and twins off, goes through a set of isolation valves, and then up into focus into a pump. Now these pumps are designed for the use with fuel oil, so they're intrinsically safe, they won't generate spark or heat, and the seals are able to cope with petrochemicals. So from that we come off the top of that, along here, through another isolation valve, and again down and through a check valve. Right. Both sides have a check valve, so that when one's pumping, it doesn't back circulate through it. So from here we come along and it would go down and then comes out of the outlet connection from the tank. In addition to that, we also have this other branch here. This comes up, goes through this valve. The valve is a lockjaw valve because this valve will only be operated a handful of times, usually when the tank is empty and it has to be primed. This is the priming valve. Priming valve comes off, comes up through the top here, and then returns into the top of the tank. Alright. The vent we were talking about, there's the vent, comes from the tank and comes back into here, so it's venting into the bunded wall area or the bunded containment area. Back to the purge valve. Purge valve, if the tank ever is ran dry or has been decommissioned for any reason, we want to recommission it. What we'd need to do is we'll shut the outlet connection off, open up the purging bypass, and manually override the pumps on the control board so that the pumps would spin up, would bleed, and it would pump back and into the tank again. Once the pumps have been bled, you flip it over, do the same with the second pump. Once both pumps are bled, we can then shut the purging bypass off. We could then open up the outlet connection, and the full force of the pump will pump the oil into the building. Next thing we're going to show you is this. This is a multi-level, so this has both high level alarm, overfill alarm, and low level. It also is connected to this device here, which this is the Bunded alarm. This is a float that sits a couple of inches above the deck of the bund. Should the bund be compromised and fill up with either rainwater or with oil from a bus tank, that float level will lift up and will set off an audible alarm. The alarm from in here is also connected into the inside the workshop in the college as well. Next thing I want to show is the vacuum operated fuel gauge on this one. So this has a connection onto the tank and can only will only read, at the moment you can see it reads 0. It will only read when you activate this by pulling down, focus, pulling that, do that, and then gives you a reading. Now if the tube that connects that to the back of this is compromised, we'll only lose the contents of the tube up to the gauge, that's all. So this is the same as a self-resetting valve on a sight gauge, it just works ever so slightly. This one works by vacuum. You see, if I do that, I get an indication of what reading it is, and that tells me what the level of oil is in there, and this gauge is now safe should it be compromised in any way, shape or form.